Okay, question, I think it's 4.9, part C. First thing I'm going to do here is I'm going to break all these forces up into horizontal and vertical components. First of all, I'll label these as force 1, force 2, force 3 and force 4. Okay, let's draw up our table of forces. So I'm going to say forces in the x direction to my right are positive, forces in the y direction going up are positive. So my table will look something like this. Force 1, 2, 3 and 4, and the sum of my forces will be down the bottom. Okay, so first thing, let's have a look at force number 1. Its horizontal component or x component is acting to my left and the vertical component is acting upwards. So the formula or the representation of the x coordinate is minus 6 cos 60 degrees. Okay, its y component, because it's going upwards, it must be positive 6 sine 60. Now force number 2, its vertical component or y component is down, which means it's got to be negative, and its x component is to my left, so it must also be negative. So the representation of the x force here is minus 10 cos 45 degrees, and the y component, because it's going down, must be minus 10 sine 45. Okay, force number 3. Its x component is positive because it's going to my right, and its y component is negative because it's going down. So the x component in this case here will be positive 20 cos 30 degrees, and its y component must be minus 20 sine 30 because it's acting down opposite to what I suggested at the start. Okay, force 4, its y component is down, so it must be negative. Its x component is also negative because it's acting to my left. Alright, so the x component must be minus 16 cos 30 degrees, and its y component must be minus 16 sine 30. Now we need to add up all the x forces and all the y forces. So the sum of my forces in the x direction is minus 6.6069 kilonewtons to my left. Now the sum of my y forces is minus 19.874 kilonewtons acting straight down. The reason why that is to the left is because it's minus. The reason why that is negative, the reason why that's acting down is because it's negative, because I said everything acting up is positive, everything acting down must be negative, and so on. So what we need to do now is we can actually draw up a diagram to symbolise that, so we know that we have 6.6069 kilonewtons acting to the left, and we also know that I have a force of 19.874 kilonewtons acting straight down. So the resultant force, or the force that I can replace both of those with, is that force. Is that force acting down that way? So that part there is wrong. Okay, so all we need to do now is we need to apply Pythagoras theorem and we can actually work out the resultant force. Okay, before we work out a resultant force, it's also a good idea to calculate an angle. So I'm going to calculate that angle of theta. All right, so let's use Pythagoras first. So we know that r squared equals 19.874 squared plus 6.6069 squared. If you put that into your calculator, you'll get r equals 20.94 kilonewtons. So that resultant force acting straight down that way is 20.94 kilonewtons. To answer this question properly, we really need to work out what the angle is so we know which direction it's acting. So tan of theta equals 6.6069 divided by 19.874. So that angle in there, theta, is equal to 18.39 degrees. So the resultant force is 20.94 at an angle of 18.39 degrees. Or alternatively, you could actually say that that angle there is 71.6 degrees roughly. Now the reason why I didn't have them as negative or that as negative is because the negative sign here symbolises basically the direction only. Okay? All right. Question D. Now D is very similar to what we just calculated for part C. So again, I am going to label these forces, call that one number 1, force 2, force 3, force 4. I will draw up my table of forces. So forces in the x direction to my right are positive, forces to my y direction going up positive. Complete that table. Force 1, 2, 3, 4. And we have our sum of forces down bottom. Okay. So let's have a look at force number 1. So force number 1, its direction in the x is to my right, and its direction in the y is going up. Okay, so because the x direction is to the left, it's contrary to what I've said at the start, so it must be minus 1000 cos 30 degrees. Right, now y is acting up, so it's positive, so it's 1000 sine 30. Okay, force 2. Its vertical component is upwards and its horizontal component is to my right. So they are both positive, so it will be 500 cos 30 for the x direction, and the y direction, vertical direction, will be 500 sine 30. Force 3 has got a positive x value only of 433 newtons, but it has no vertical component, so I'll leave that as 0. Okay, force 4 has got no x value, but it has a minus 750 Newton y value is acting straight down. Okay, the next thing I will do is add the sum of all my x's, and if I add all the x values up, I end up with minus 0.0127, and my x's end up being 0. So there is no resultant, and the system is in equilibrium.